Hello 8th grade Grizzlies. This is Miss Brown, and in this review video I am going to go through question by question and give you the answers to the plate tectonics test review. Alright, so let's begin. So when we started this unit, we started by talking about Alfred Wegener and his theory of continental drift. Okay, so his theory of continental drift was that the continents were all once joined together in one giant landmass that he named Pangaea. And the basis for his continental drift theory was based on 4 pieces of evidence. Okay, so we're going to look at this picture. And we're going to pick the answer choices that were part of his 4 pieces of evidence. Alright, so continents fit together like a puzzle piece. That is one of the 4 pieces. So if you look at the coast of South America and the coast of Africa, if you were to move this over here, it fits like a puzzle piece. So yes. Similar fossils of plants were found across continents. Yes, that was also another one of his theory. He found fossils of tropical plants in cold regions where those plants could have never survived. Alright, evidence of glacial markings were found in current tropical regions. Yes. And this piece of evidence was known as climate. So basically they found glacial scratches in tropical regions. And we all know that glaciers need to be in a cold climate. Okay, and then matching fossils of land animals were found on different continents. Yes. Okay, so all of these were pieces of evidence. And what you might have seen in your various classrooms as your pieces of evidence was 1, Pangaea, 2, fossils, 3, climate, 4, landforms. And when we said landforms, he found that there were mountains on another continent that matched exactly mountains on a different continent. Okay, so you might have seen these 4 pieces, you might have seen the evidences listed this way. Okay. Alright, question number 2. According to the map, which evidence best supports the idea of Pangaea? Alright, so Greenland and Europe have matching mountain chains. So if we look at Greenland and we look at Europe, that is correct. And that goes along with landforms. Okay, matching rock layers can be found in North America and Europe. Okay, so here's North America, here's Europe. Again, this goes along with the landforms evidence. So that is a piece of evidence. Antarctica and Australia have similar shapes? No. And then Africa and India have glacier scratched bedrock. Well, here's Africa and here's India. Okay, and we did say that climate was one of them, where they found glacier scratches in a warm climate when we know that glaciers need a cold climate. So yes, that would be a piece of evidence as well. All right, moving on. All right, number 3, scientists have discovered glacier scratches in India. Again, this is climate evidence. Using the pictures below to help you, what would be the best explanation for their discovery? Okay, so here's India. This was India during Pangea, and this was India during Pangea, and this is India today. Here's Antarctica right here. Okay, so what would be the best evidence of why you would find glacier scratches in India? India was once joined to Antarctica. Okay, that's the only explanation that would explain why you would have glacier scratched bedrock in India when India is in a warm climate. So it was once joined to Antarctica. All right, moving on. So now we're moving into talking about plate boundaries. And let me just review the plate boundaries very quickly before we go into this part. Okay, so your plate boundaries. We have convergent, divergent, and transform. Okay, so those are your different plate boundaries. So convergent, they're coming together or they collide. And also with a convergent boundary, you can have subduction, which is a process where a denser plate sinks underneath the less dense plate. Okay, divergent, you divide. So that's where plates are pulling away from each other. And then your transform boundary, they slide. So they slide past each other. So you might see arrows like this, arrows like this, or arrows like this. Alright, so we're going to quickly go over the different geological features. And when you hear the word geological feature, that just means a type of landform. Alright, so for convergent, there's three different types of convergent boundary crests that can come together. So you have continent to continent, ocean to continent, and ocean to ocean. For divergent, you only have two, continent to continent and ocean to ocean. And then for transform boundary, it's just continental crest. Okay, so at a convergent boundary, when you have two continental crusts coming together, continental crust is the same density. So when they come together, you're going to get a mountain. Because what happens is that crust collides, and because it is the same density, neither plate sinks or subducts. So it just keeps piling up and up and up and up and makes a mountain. Okay, remember, when you have ocean to continent or ocean to ocean, anytime you have an ocean plate involved, you're going to get some type of volcanic activity. So, when you have two ocean plates, when you have an ocean and a continent coming together, the ocean plate is more dense. It's going to sink your continental plate. So your ocean plate is going to sink under your continental plate. and that's where you're going to get a volcano. Okay? Now, if you have ocean to ocean, usually the older plate will sink, but one of the ocean plates is going to sink, and that's where you get a volcanic island. So here's my water, and there's my volcanic island. So what I tell my students, ocean to continent, you get a volcano on the land. Ocean to ocean, you get a volcano in the water. Just remember, whenever there's an ocean plate involved at a convergent boundary, you're going to get something volcanic. All right, on to the divergent boundary. Divergent boundary, you have two plates moving away from each other, so two continental plates moving away from each other. You're going to get a valley, and we say rift, valley, or you might just see rift. So basically, the plates are going to pull apart and you get a valley. All right, when you have two ocean plates pulling apart, this is where I noticed a lot of students were getting confused. When you have two ocean plates pulling apart, you get something called a mid-ocean ridge. So if this is my ocean plate and they're pulling away from each other, what happens is that magma, as the plates are dividing, that magma comes up through the center, and when it hits the water, it hardens and makes a mid-ocean ridge. I know a lot of people were saying, oh, two ocean plates divide, you get a valley. No, 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 no. Because when they divide, that's where the magma comes up through the crack when those plates pull apart. All right, and then at a transform boundary, you have two land plates sliding past each other. The event that happens is an earthquake. And the geological feature, or what happens, you get something called faults or fault lines. So anytime you see fault or fault line, that is a transform boundary. Okay, and this, what I did right here, is also a brain dump activity that you can do right before your test, just to dump out all that information from your brain and to get it down someplace so that it's out of your head and you can use it during your test, okay? All right, so I'm going to move back to the review sheet and continue. Okay, so what type of boundary occurs between the South American plate and the African plate? All right. So we have the South American plate here, and we have the African plate. So what type of boundary is occurring right here? The arrows are moving away from each other. So we have a divergent boundary. Sorry about that. Okay, next question. What type of plate boundary occurs between the Nazca plate and the South American plate? Okay, so here is the Nazca plate. Here is the South American plate. Okay, so what is occurring? That is a convergent boundary. All right, on to number 5. Okay. And it says, during the process, oh wait, where's my number 5? Okay, let me do number 6 and figure out what happened to my number 5. Okay, let me do 6 and then I'll come back. All right, number 6. During the process of subduction, what happens to the plate that sinks underneath the other plate? Okay. So it causes cracks in the mantle. The magma will rise and form a volcano. Okay, so here you have the ocean plate sinking. Okay, this is the subduction zone where it sinks. Okay, it makes cracks in the mantle, and then this is where the volcano forms. Okay. All right, I'm going to pause for just a second so I can find number 5 and go over that one with you, because for some reason my review sheet skipped number 5. So I'm going to... Okay, I found my number 5. So let's go back to that real quick. Okay. So number 5 says, a chain of volcanoes exists along parts of the west coast of North America. What is the name of the process that formed these volcanoes? Okay, so remember, a volcano forms when an ocean plate sinks under a continental plate, you get a volcano. And then if an ocean plate sinks underneath another ocean plate, you get a volcanic island. So the process is subduction. And that was that ring of fire that we talked about when we did the map activity last week, I believe. All right, onward. All right, so we're on to number 7. So we want to label this model here, or this picture. All right, so this is ocean crust that we're dealing with, okay? So this is one ocean plate moving away from another ocean plate. So this is a divergent boundary. Okay. Over here, I want you to put continental crust. And over here, I want you to put continental crust. So the continental crust will be moving this way, and this continental plate will be moving this way. All right, now we can fill this in. Section A is an example of what? Okay, two oceanic plates pulling apart. That magma comes up in the center. This is a mid-ocean ridge. And this occurs, like I said, at a divergent boundary. All right, what sort of boundary would occur along section B and section C? Okay, so B is here. This is the ocean plate. It's converging with a continental plate. So this ocean plate is going to sink. Over here, you have an ocean plate converging with a continental plate. This ocean plate is going to sink. So you have a convergent boundary at B and C. And then it wants to know the process that's going to occur. That is subduction. So like I drew out here, that ocean plate is going to dive underneath that continental plate. So you're going to have subduction of the more dense ocean plate. All right, onward. Number 8, where would you find the youngest rocks in the ocean and why? Okay, so we're going to look at this picture. So right here you have two ocean plates separating. So this is ocean crust and ocean crust separating. So remember, when two ocean plates pull apart, that magma is going to rise and it's going to form a new rock. So the new rock is going to be at letter A here. We'll call this letter A. And this is divergent. Okay, so the new rock is going to be at the mid-ocean ridge. Okay, so the youngest rock is where the magma rises. So the new rock is going to be at A. As these plates continue to move apart, what happens is new rock forms here. The old rock is going to be out to the side. So this is going to be old rock. So your old rock is going to be here, and you're going to have old rock here. Okay, so your new rock is at the mid-ocean ridge. All right, back to Alfred Wegener, number 9. Why didn't people believe Wegener's theory of continental drift? He had all the evidence, but he could not prove how the continents move. Okay. And now we know that the convection currents in the mantle is what causes the plates to move. All right, onward. Which of the following was not evidence that Wegener used to support his theory? Okay, so remember his theory had 4 pieces of evidence. So we had Pangea, we had puzzle pieces, landforms, fossils, and oops, so Pangea and puzzle pieces all one. Should have done those together. So Pangea / puzzle pieces, landforms, fossils, and climate. And the climate was, again, that he found warm plant fossils of warm temperature plants in cold environments. And also he found glacier scratches in India. And again, India is a warm climate. And glaciers need to be in a cold climate. Okay, so which one was not evidence in his theory? And that was the existence of convection currents. That was the one piece that he could not prove, or he didn't know at the time. So this was part of his theory, this was part of his theory, and this was part of his theory. Okay, 10. We did not talk about Harry Hess, but Harry Hess came along later after Wegener passed away and helped him. He helped Wegener's theory because he discovered seafloor spreading. All right, number 11. What process in the mantle causes the plates to move? That is your convection currents. So convection currents in the mantle is what causes continents to move. All right, number 12. Which of the following could cause the formation of solid mountains? When we say solid, we mean non-volcanic. So that is 2 crustal plates colliding, because crustal plates means land plates or continental crust. Continental crust does not subduct. So when they come together, it just keeps piling up and up and up and up and up. All right, number 13. Which of the following forces would cause mountaintops to change from pointy peaks to smooth and rounded? That would be erosion and weathering. And that's a 7th grade concept you talked about last year. And for this one, I just added crustal plates colliding continent to continent. Okay. And then for this one at the bottom, or S, weathering and erosion. So you might have mountains that look like this with weathering and erosion over time. They're going to look more rounded. Okay. All right, next page. All right, you can cross these 2 off. I'm not going to do those. All right, so here's your word bank off to the side. So when one plate sinks below another, we call that area a subduction zone. The main points of evidence for the blank theory are fossils, landforms, and climate. That was the continental continental drift. Valleys form when two plates, I think the word over here is diverge, or divide. All right, blank determines which plate subducts, that is density. And remember, your ocean plate is more dense. Okay. At a blank boundary, plates move towards each other, convergent. A mid-ocean ridge forms at a divergent boundary. Earthquakes are caused by transform boundaries. So remember, transform is when they slide past each other. Divergent divide. Convergent collide. All right, large mountains form at a convergent boundary. And remember, you get plain old mountains. It is continent to continent. A convergent boundary with ocean to ocean forms volcanic islands, or sometimes we say volcanic arc islands. We're just going to say volcanic islands. So that is at a convergent boundary. Ocean to ocean. And volcanic mountain ranges, that is also a convergent boundary, but this is the one where you have the ocean that sinks and the continent. All right, next section. All right, it wants you to put a circle around divergent. So anything that represents divergent is going to be a circle. Anything convergent will be a triangle. And anything transform will be a box. All right, so let's start with our transform boundaries. Okay? So tsunamis occur at transform boundaries. It's basically an underwater earthquake. So we're going to put a box around earthquake. And we're also going to put a box around this because that is the plate movement direction for a transform boundary. All right, let's do triangles for our convergent boundaries. All right, volcanoes form at convergent boundaries. Again, it's either ocean to ocean or continent to ocean. Either one of those is going to give you some type of volcanic activity. All right, these two arrows represent subduction, so that's at a convergent boundary. The word subduction, that's convergent. And then large mountains would also form at a convergent boundary, continent to continent. Okay, and then we're going to circle our divergent boundaries. Rift Valley occurs at a continent to continent divergent. Those are the arrows for divergent. All right, last page. All right, last page, we're going to label this picture. I am going to do a separate video on this part of the review because this is a topographic map and I want to do a little extra practice on topo maps. So I'm going to do another video. It's going to be on topo maps and then I'll fill out this part. All right. So letter A. This is our word bank. We're going to label each part. So letter A. All right. So this is ocean crust. Moving away from ocean crust. This is magma. So A is a mid-ocean ridge. All right, letter B. All right, so you have an ocean plate that is subducting right here. That is a deep ocean trench. All right, letter C. Okay, this is an ocean plate. Ocean plate. So letter C, these are volcanic islands. So all of this is ocean crust. All right, letter D right here where it's diving under, that is a subduction zone. And E is referring to what goes on in the mantle. That is your convection currents. Okay, so I am going to close out this video right here because we have gone over everything to do with plate tectonics and continental drift. So I'm going to close out here. Again, I am going to do a separate video that's going to go over topographic maps again, and then I will fill this part of the review sheet in off of the topographic map video.